is James Black, and today I'm going to be talking about Kotlin Multiplatform. So, the basic idea is you want to have one application that can run on one code base, basically, that can run on more than one platform. So, for example, we have here an application that's running on Android and on iOS, and I'm still in the process of writing it, but this is a starting point. And you have the iOS version, which minus one little tab at the bottom is basically the same. So the goal here is to look at how can we do this. The nice thing about Kotlin multi-platform is you can do it not only with the with mobile, so you can put it on the web, you can put it on the but you can also do desktop. You can do Mac OS, Linux, Windows, watches, tvOS. So any platform you can have, your code base can be all under one umbrella. And the basic approach of most applications nowadays is something along the lines of you have a UI component, views, whatever. They talk to a view model, which goes to a repository, which goes to a remote API, which goes to the cloud. You can also have where the repository can talk to local storage. So in Kotlin multi-platform, what you do is you would talk to the view model still, and then the view model will actually be only using one of these platform-specific view models for when it's installed on a device. So if I'm running on an Android, it goes down the Android path only is what's compiled in. If I do the iOS, it goes down the iOS path only. But you abstract out the platform specificity to the correct platform. So you go to the store, and then you would go to local storage this way, or you go over here. So that's the basic idea. So let's talk about how do you build this, because the hard part really for me is the setup. So what we're going to be going over is you download Android Studio, and we'll be going through this list here, but I'm going to be just showing you largely how it's done. So you start with going to kotlinlang.org, and under multi-platform development, if you go with the get started, they will show you how to set up the environment. So when you set up the environment, they talk about downloading Android and Kotlin and all that. So you get yourself set up first. And then while you're going through and you want to look for examples, John O'Reilly has some incredible blog articles and repositories. These repositories deal with Kotlin multi-platform. So you can look at lots of different examples of how to do work in it. I got a lot of influence from the Cat Viewer demo, only because he was the first person to show how to use a shared view model, so that I had one view model that that all the applications could use. That way, the only thing that's really specific for each of my platforms is just the UI components, which I like. One of the things about Kotlin multi-platform that's great is it has a large number of libraries. And this repository in particular, I really like because it tells me which platforms this library will work on. But it has a phenomenal number of libraries that people have written. So I'm a big fan of this Akira library. I like the way this one looks. My only problem with it is, I also like this little picture here. My only problem with it is it doesn't tell me which platforms things run on, but I think they may have more libraries on here than the other one does. So I bounce between the two because for it, you don't want to keep reinventing the wheel, especially when in iOS, when this compiles, it compiles the native code for iOS for the iPhone, Mac, or whatever. So it creates a C library. So your library has to be able to be in a way to where it can compile to that. Um, I'm not interested in trying to write that. So what you do is you'll have, after you have gone through the setup, you will have these a plugin for Kotlin and for your Kotlin multi-platform. And then you just go to here, you say new project, and then at the bottom, it will give you this one. You use this one here, not that one. You say next. Then you put a name for your application, the SDK you need that you want to support, what you want to call. I tend to leave these the same names. And whether you want to use CocoaPods or not, I tend to use CocoaPods because it's built in. So, and then you would create the project, and you'll get largely a blank project that will work on both the that's already set up so you can run it in iOS and in Android. So the only thing is, so the iOS one is set up for SwiftUI, the Android one is set up for Fragments. So I'll be walking through how to start with a project that you're copying. I would not recommend just cloning it and then just changing the fields you need. I think it's a lot more work to do that than to actually just copy over the parts that you need. So to start with, I got this from John O'Reilly, but you would start with creating a build source folder, and then you'd make the source main Java, and then you'd create your dependencies. So these are all the dependencies that, for example, my application uses. If you're not going to be using some of these, or if you're going to be using others, you just add them in. Now, one thing that's important is I'm using JDK 1.6.10. The reason being because I'm using Compose. And right now, if you go to the Compose to Kotlin compatibility map, you will see that the most recent version of Compose can only work on 1.6.10. So even though 1.6.20 is out, I can't use that. If I was not using Compose, I could use 1.6.20 if my other libraries supported it. But since I like Compose, at the moment, that's as high as I can go. So you start with, one of the first things you want to do is look and see if I'm using Compose, what's the most recent version, and then that sets which version of Kotlin you use. So you'll see that here, for example, I have this version. And so these are, you put, this, it actually seems to ignore. So I think it uses the compile version, but the min version gets ignored. So, and so you would figure out which libraries you need, and you could put them in here. Then what I do is I build this right away. After I create the file, I build it, make certain it all can pull down the correct, that it can build properly. Because then the next step is you would go to the build.gradle actually for the project, and you make certain that you have all of the repositories you're going to need. You could just, in actuality, what you could do is you could just copy this whole thing and just paste it in where you're doing it in yours. This one you could just copy whole hog. An important part is to look at your Kotlin version here, or set it if it's not set. I don't think it gets set by default. And then these keys here are, I just typed in characters, but I'm going to be using them in my code. So I'm using build config with a K to make it to where I can have my properties in a Gradle file, Gradle.properties, and it can pull it into the code. So, and then at this point, when you make any changes, it will actually say sync now. So you just sync at that point, and it will start to update its internal configuration. And then you go to under the shared folder, you would go to the build.gradle. And here's where you can't just copy it whole hog. You have to kind of look at what you're doing. I'm using build config, so I had to include these imports at the beginning. And then you could largely copy the plugins until you figure out exactly which ones you need. It doesn't hurt to have more plugins than what you're actually using at times. I took this one out because it was actually causing a problem for me. So at some point I may go back to it, but I don't know yet. Your system comes with, it'll be built with these 4 subprojects, basically. Android and the iOS ones for the older chips and the newer chips. I added JVM because I have a backend that I am using. You want to make sure that your CocoaPod file here, version here, is correct. It defaults, I think, to 14.1. I do want to do 15, so I just changed it there. I had to change it, I think, in 3 places total. 2 in Xcode and 1 here. And then you just start going through. So these dependencies, anything in common main, will be used by any of the main projects here. So Android main, iOS main, JVM main, all will be able to pull in code from common main. So these are where you start putting in more specificity for your platform, is in these outlying mains. So for example, if you want to, and it builds with this, but if you, for this line here, if you wanted to see how to get a string name, you would, the platform version, you would use this. On iOS, it's different. So you build in so that's what those are for. And those are critical. But you first start with setting the dependencies in the common main, because this is what everything will use. And so I put in these. And then you also have your common test, same thing. Each one of these can have their own test, and you will then see how to, that they can all pull from that. But I also have certain things that are specific to just, for example, Android. So like my Ktor is my web service library, HTTP library that I use. So it has a client, it has an Android library. So I use that one here. And then I also am using a data store and a lifecycle model. And so I have some dependencies that are just for Android. And then I have some, like Ktor, that are just for iOS. So you go through and you set those up. This actually does matter. So you want to make certain you have the correct versions here that you're supporting. And then I put this in here. So one of the problems I run into is sometimes you'll see, you almost want to, I'm trying to think if there's anything in here. You could basically copy this entire file minus this part here into your file, and then just make modifications, because sometimes it complains that there'll be more than one clean task, for example, and that causes problems. So I found it easier to do it that way. So at that point, then you change the Gradle, so you re-download everything. At this point, I would run everything just to make certain that it will work anyway. You haven't tied anything except for the platform call to the shared library, but you want to make certain it all runs. That's what takes us so long is to set up initially is I constantly run as I'm going along. Okay, so in order to be able to have this work in a smooth way, I use dependency injection. So I use the coin library. So the next step is to set up the coin library. And so that's under common main. And what you do, you could largely copy this and paste it somewhere. But then what I do is I start off with, this becomes my map of how to set up everything. I just comment everything out except for this. I don't comment this out because it's created right there. So if you're not going to be using any HTTP connections, you don't need this. You can lose the first two, actually. But if you're using them, this isn't a bad approach. I commented it out, I think, because at one point I was having some sort of an issue. I just haven't gone back to look at it yet. So that is, so that's what I do, and then I would build this, run it, make sure everything works. Now, if you want to start incorporating these changes directly into your code early, you can do that now. So what you do is for Android, in your application, you would just, in your onCreate, just call initcoin and pass it largely these. And it will, at that point, it'll have initialized the dependency injection. For iOS, now in actuality you would do this in Xcode, but it's easier for me to just show you here. But it comes with these 3 files here, what it comes with. So, but in order to get dependency injection to work, I added an app delegate, and then I call do initcoin here. But to call the app delegate, I go to iOS app, I just add this one little tag here. You'll see that John O'Reilly and others will comment out this main tag and put the main tag on app delegate. This way to me seems cleaner, simpler, because then you don't have to go in and change the info plist for the scene delegate and all that. This just seems less painful. So that's what I do now. And then at that point, now you could run it and it will initialize everything and make certain that it still works. So, and then I just start going through and just I'll uncomment out the first part and say, okay, I need to create an API. So I go to remote and I just follow kind of the pattern and I just start to create an API. My API calls, what's it going to look like when I call the other side? Here's where I get my API key. And so that way I don't have to include it in what I'm committing to GitHub. And you just kind of go through. So you say, okay. Now what I did is I actually made a test for this. Thought I made it. Guess I got rid of my test. Oh no. Okay, remote. Okay. I made a test to make sure that it works. So you could do that also because you're only going to have one remote API in the entire application. It's not going to be made, it's not going to have a specific different versions for different platforms. You're going to have one. So it's easy enough to test to make certain that it works. So you set that up, and then you rerun everything. When you when you build when you make your project, sometimes you'll find that it will complain that it can't find certain files. I just do a rebuild project, and it seems to fix everything. So at times you have to do a rebuild if make project doesn't work. It's a little annoying, but this is still an alpha. So, and then you run it again. Make certain everything is still working, that you didn't break anything. And then I just keep going through and just commenting out each of these. Some of them take more work than others to get set up, to take longer. The repository has, much like you see here, it actually has versions for each platform, and they will go to their own local storage. So when you go to build your repository, even though it's one little file here, eventually this will call the API, but it will also call the functions to save to cache data. So you can start doing it here. I just right now have it doing a basic pass through to Weather API so I can cache it later. But then you have to go in. Oh, forgot for dependency injection also. Did I? No. Okay. So okay, so the only reason I have this is there's a idiosyncrasy in. I was trying to think why this was here. There's an idiosyncrasy right now for some reason in my server code. It's actually using Android main, not JVM main. I'm still trying to figure out why. I think I set up something wrong. So I have more things in my Android main than I should, only because I'm dealing with that idiosyncrasy. That's why this weather API is here. You'll see that in iOS main, I don't have that. So I just have a view model. In my case, because of the way that I set everything up, it'll actually go to settings, which is kind of a repository. So the repository in my setup is built of several components. And so settings is where I would go to like NS user defaults to save data at the moment. So, but you just basically start going through and you look and say, okay, let's look at the repository. Let's set this up, and then we build it. And then you figure out what breaks. And then you go to the next part. Gradually, when you get to the shared view model, you actually have more breaking because now you're starting to pull pieces together. So like you have to use a weather repository here. The weather repository called the weather API. Shared view model calls these two, or it calls this one, which calls that, which calls this one. And then you have this view model will extend this view model, and we'll use the store, which is actually also calling settings. Well, setting storage, which calls settings. So all of the pieces will eventually be calling each other. So as you start going through and you start looking at what they each need, it will tell you what you need to build next. And as you build each piece in Coin, you just rerun the entire application. So when you finish with the repository, you rerun it. When you do the view model, you rerun it. The outfit picker store, rerun it. And then eventually you have everything done. Okay, now we have the shared area done. It's, like I said, it could take a day or so to get done. It's a fair bit of work. But now the only thing you have to really do is create your application, your UI. So all that pain is so that now each platform You just have to focus on the UI. If I have to add something, if I realize, oh, I need to have this, then I go and I add it to the appropriate view model, and then I will have it for all my applications. So for example, in this description here is from one of the view models. This ID came from a repository which looks in the local data storage. These are actually an enum from the view model. So everything is identical. They're all pulling from the same data sources, which makes it easier for me to not have to make certain I keep everything in sync across different platforms, because that can be painful. And that's basically it. In the iOS side, I did, like I said, there was some other changes I had to make. I just had to make certain that I had the correct version. See, obviously you have to change that. You just set your signing. You make certain your deployment target's the same. In your pod file, you make certain that's the same. So you do have to keep these kind of synced up. And at that point, you're ready to start building. If I want to add a web front end or a desktop front end, all I'd have to do is make it work inside here, and then I just have to worry about the UI components. So it makes it easy for me to extend it out. And that's about it. If you have any questions, please let me know. But have a great day. Bye.